Deductive reasoning. Objective: to use the law of detachment and the law of syllogism. Deductive reasoning, sometimes called logical reasoning, is the process of reasoning logically from given statements or facts to a conclusion. Law of detachment. If the hypothesis of a true conditional is true, then the conclusion is also true. The symbols would be if P then Q is true and P is true, then Q is true. So if we have an if-then statement that's true and we know that the hypothesis is true, then the conclusion is also true. And this should make sense from the previous section, because when we did the 4 cases, if the hypothesis was true and the if-then statement was true, the conclusion also had to be true. If the conclusion was false when the hypothesis was true, then that led to a false if-then statement. Example 1 says, what can you conclude from the given information? If there is lightning, then it's not safe to be out in the open. Marla sees lightning from the soccer field. Conclusion? Okay, it says if there's lightning, so here's the hypothesis. The conclusion, it's not safe to be outside. So here's Q. And it says she sees lightning, so that means that P is true. So what can we conclude? We conclude that Q also has to be true. So we can say for a statement, our conclusion is that Marla is not safe out in the open. If a figure is a square, then its sides have equal length. The figure ABC has the sides of equal length. Now on this one, we have that a figure is a square, so there's our hypothesis. Our conclusion, then it has equal sides, or equal length, sorry. Here's Q. But it says that the figure has equal length. That means that Q is true. So on this one, there's no logical conclusion that can be reached, because if we know that Q is true, this doesn't serve the law of detachment, because we needed to know that P is true in order to assume that Q is true. Law of syllogism. The law of syllogism allows you to state a conclusion from two true conditional statements when the conclusion of one statement is the hypothesis of the other statement. Symbols. It says if P then Q is true, and if Q then R is true, then if P then R is true. This is kind of like the transitive property that says if A equals B, and we know that B equals C, then we also know that A equals C. An example, it says if it is July, then you're on summer vacation. If you're on summer vacation, then you work at a smoothie shop. Your conclusion, if it's July, then you work at a smoothie shop. What can you conclude from the given information? What is your reasoning? It says if a whole number ends in 0, so a whole number ends in 0, that's P. It says then it's divisible by 10. So is divisible by 10, that's Q. It says if a whole number is divisible by 10, here's Q again, then it's divisible by 5. So here's R. Now notice, this is where we can get rid of like the middleman. So now we can say, because we've said if P then Q is true, and if Q then R is true, so now we can jump to say that then if P then R must also be true. So our conclusion can say if a whole number ends in 0, then it's divisible by 5. Because this middleman right here can be cut out. So now we have if a whole number ends in 0, then it's divisible by 5. Okay, the second one says if ray AB and ray AD are opposite rays, then the two rays form a straight angle. Okay, so we want to identify our hypothesis, if our Q. If AB and AD are opposite rays, so here's P, says then the two rays form a straight angle. Okay, so two rays form a straight angle. Here's Q. It says if two rays are opposite rays, so two rays are opposite rays, here's R. Now notice the difference between R and P. P is saying if AB and AD are opposite rays. They're talking about these opposite rays. The other one says if two rays are opposite rays, then the two rays form straight angles. So again, the two rays form straight angles. That's Q again. Okay, is there any conclusion that can be reached? We have if P then Q, and we have if R then Q. Well, no, because we do not have that if P then Q, if Q then R, then if P and R. So this is where no conclusion can be reached. Example 3, it says, what can you conclude from the given information? What is your reasoning? If a river is more than 4,000 miles long, then it's longer than the Amazon. If the river is longer than the Amazon, then it's the longest river in the world. The Nile is 4,132 miles. Okay, so we start off with if a river is more than 4,000 miles long. So here's P. Then it's longer than the Amazon. Here's Q. It says if a river is longer than the Amazon, so there's Q again, then it is the longest river in the world. So now here's R. And now it says that the Nile is 4,132 miles. Now notice here we have the law of syllogism and the law of detachment working together. First, we can use the law of syllogism that says we have if P then Q, and then if Q then R. So now we can jump to say if P then R, which says if a river is more than 4,000 miles long, then it's the longest river in the world. Okay, so that's by the law of syllogism. But now by the law of detachment, we know that it's saying that the Nile is 4,132 miles long. So now by the law of detachment, we can say then the Nile is the longest river. Because we have that the hypothesis is true, we have a river that's more than 4,000 miles long, then we're saying R is true, that it's the longest river in the world. So the conclusion, the Nile is the longest river. Does it matter if you use the law of syllogism or the law of detachment first? Explain. Well, if we go back and we look at this, the law of syllogism first and then the law of detachment. So if we work backwards and say the Nile is 4,132 miles. Well, if we did the law of detachment first, it says we'd probably use this statement right here. It says if a river is longer than the Amazon, then it's the longest river in the world. Okay. Now notice here we're saying that the Nile is 4,132 miles. But if we use this statement, we don't know the length of the Amazon. So now we have to go back to the first statement and see if we can use that to use the law of detachment. If a river is more than 4,000 miles long, then it's longer than the Amazon. Okay, so we could use the law of detachment here that says if a river is more than 4,000 miles long, then it's longer than the Amazon. We have that the Nile is over 4,000 feet, or 4,000 miles. So we have a statement now that says the Nile is longer than the Amazon. Then we could go to the second statement that says if the river is longer than the Amazon, which the Nile is, we've already proven that in the first statement, then it's the longest river in the world. So now we can conclude that the Nile is the longest river in the world. So you could do it either way on that one. But the way the sentence is written or the paragraph is written, logic would say law of syllogism and then law of detachment. Lesson check. You need to try these 5 questions before you come to class next time. We'll go over them in class to make sure that you understand what you're doing before you start your Math Excel.